Here's an explanation for the code for Activity 3 project. There's a number of different ways to do this, but I highly suggest writing out the steps in a sort of algorithm ahead of time so that it makes it easier to program. First, I've declared a number of variables up here. I've got red LED for the LEDs, timing, which is starting at 1,000, button, which is what my button is wired to, and then button state, which is for storing a temporary variable. In void setup, I've told the button input to set it to low so that it's grounded. That's not necessary usually, but with Tinkercad it has some glitches every once in a while, so it's helpful. I turned on serial begin, and then I used a for loop to turn on outputs 3 through 11 by creating a loop that goes through 3 through 11, incrementing one at a time, and then putting I, output. This was talked about earlier in the lab in one of the previous videos. In loop is where I've controlled the zigzagging of the lights. In the first section, we basically turn on our 9 LEDs by setting up a for loop, similar to how we did in the setup window. Named each one red LED, and that way each way through the loop, this next light turns on. And then I serial printed the pin number and the pin number string and the red LED showing the pin number on the screen. Normally I do not stack programming lines like this horizontally. I only tend to do it on serial print and serial print ln so that you can see them showing up on the same line as they do in the actual serial monitor. We're going to ignore this part for now, and then we turn the LED off at the end of the for loop. This part here represents the delay, and so I would highly recommend to program at start, if you're programming in this method, to just use a delay 1000, and then we can replace it with a for loop. Similar to how you did question number 8 in activity 2. And then for going backwards, we're going to go for 10 to 4, red LED minus minus. We're not using 11 and 3 on here for going backwards, because then the end lights stay on for a longer period of time than the lights in the middle. Because it was usually when it's on LED 3 or LED 11 and stopped there, when it continues it just goes back to 10. It doesn't need to go back to itself on 11 or 3. We do the same process again. So if you get this loop to work, you just copy and paste it again, reversing a few numbers to make it count backwards. For the delay, I used a for loop similar to activity 2. For the delay, I used a for loop and started at 1 and went to less than or equal to timing, whatever the variable is stored in that number. It started at 1000. And then I delayed for 1 millisecond and did a button press look, running a function during that one loop. While this works okay on Tinkercad, I don't usually recommend doing a single millisecond delay within a for loop, because every time the code exits to go run the void loop, the void button press loop, and then comes back, it may take a very short period of time to do that, depending on what code and calculations you have going on in the loop. In the long run, this can seriously affect timing. especially when serial printing, because if you're serial printing at 9600 baud, that print rate can slow down your computer, the delay timing, due to the fact that the megahertz of the chip is much higher than 9600. So it has to slow down the printing to the screen to 9600 times a second, whereas it checks more often than that. I would more likely recommend divide your timing by 10 and then make your delay 10, or divide your timing by 100 and make your delay 100. So that it's a little bit slower process, and the Arduino can handle it in real life. So, in the for loop, it goes to the for loop for the length of time it takes to do the timer, and looks for the button press each time. There may be a small delay in looking for the button press if the code is running and it is outside the loop, but this whole process should take, to get back into the for loop each time through the light sequence change, should take less than a millisecond or two, so it shouldn't be too bad. Again, it's mostly affected by serial print. Again, going backwards, we're doing the exact same thing. We run a 1000 millisecond for loop, delaying it 1 millisecond each time through the loop, and doing a button press check. Now if I go down and look at my button press, I can see I've made a function using an if statement. So if the button is not pressed, it should return. Normally I find in using a real Arduino, you don't necessarily need this return here, because if the button's 0 state is achieved, it shouldn't execute the else and should automatically jump back into where it left off. Tinkercad, I find, has been programmed to look for the return, and if it doesn't see it, it acts a little bit weird. If you can't get your code to work completely, but you feel you have the right structure, you can go ahead and turn it in, and I'll take a look and see if we can figure out what some of the issues are. So if the button is pressed, the if statement is no longer true, and therefore it completes the else statement, so it looks for the button. So it turns on the LED again, which technically just leaves the LED on that was on prior. It prints to the window pressed, and then it has a small delay to allow you to let go of the button. Otherwise, it will react too fast because you can't press a button within 1 millisecond. After that small delay occurs for letting go of the button, it uses a while statement to look that the button stays low. This part here could occur using a button state, not button state comparison as well. So on my example, it just kept showing not pressed 2, and I had used the letter 2, the number 2 there to signify I was in the second part of the loop. So I kind of knew where I was based on what was going on. And then it has a short delay, again, so if you push the button, you have a chance to let go of the button before it goes to the next section. So it will stay in this while loop because the button state is low until the button is pressed again to exit this while loop. The immediate time the button is pressed, the while loop exits. A while loop responds much faster than an if loop, usually, as long as I'm not pressing the button during this delay 250, because the while loop is looking during the process, not only at the start or at the end like the if loop is. So once the button is pressed a second time to exit the loop, it turns that LED off, it says pressed again, and then it subtracts 100 milliseconds from the original timing variable. So as I press the button each time through the loop, it's going to subtract a little bit more time. This is one way to do it. If you feel you have a different way, try writing it that way and explaining it with your algorithm. And then, if you run into programming troubles, break it down into steps, solving each chunk at a time.